Hello and welcome. You're watching Lockdown TV from UnHerd. So we've talked a lot about the pandemic and science on this channel. We've also talked a lot about politics and philosophy. Well, today's guest is a bit of a different one for you, but in a way it's the fusion of those two themes. His name is Merlin Sheldrake. He's just finished a fascinating book called Entangled Life, which investigates the hidden and mysterious world of fungi. Merlin Sheldrake, thank you so much for coming into our pop-up studio in Westminster. I've finished and greatly enjoyed the book. I should start with a confession, which is that I am myself a very amateur mycologist, as in mushroom enthusiast. Many a childhood summer in Sweden enthusiastically picking chanterelles and becoming quite obsessive as to where they tended to crop up year after year. What is your origin story with the mushroom world?
There are a few ways in for me. When I was a child, I was very concerned with how things change. How does compost form? You know, when you take a bucket of compost outside and it turns into soil, and how does this happen? And how do piles of leaves, I used to like hiding in these piles of leaves as a very young child, and they seemed to sink into the soil. And so I became interested in this process of decomposition that seemed to happen out of my sight and yet so noticeably at the same time. And so the more I thought about the organisms that decompose the world and the more questions I asked about these organisms, the more I was led to these mysterious fungi that seem to oversee so many of these natural transformations. So that was one way in. Mushrooms, of course, another, because they're so striking. And I used to grow mushrooms as a child, and you can almost watch them grow. They grow so fast, and so that was always a thrill. And then the subject of symbiosis, which I became more and more interested in as I studied biology, and the ways that organisms have found to live together in very intimate circumstances. And so when you think about symbiosis and the history of symbiosis, you can't go for long without running into fungi, who are major players in some of the big blockbuster symbioses that have really shaped life on the planet. And so that was what took me into my interest in symbiosis between plants and their symbiotic root fungi.
So you've spent years now, you've been in Panama, you've been in Sweden, you've been researching the fungal world. Let's start with the basics for our audience. So what we think of as mushrooms, which are basically the visible fruits of a fungus, is actually only the tip of the iceberg. And actually, there are these whole things called mycelial networks, which are everywhere in the soil underground. Give us the kind of intro course on that.
Yeah, so when we think of fungi, we normally think of mushrooms, which, as you say, are the fruiting bodies, equivalent to apples on a tree. But most fungi live most of their lives as mycelial networks, which are branching, fusing networks of tubular cells. And these mycelial networks are how fungi feed. So fungi don't do as animals do and put food in their bodies. Fungi put their bodies in their food. And mycelium is the most efficient way to do so. And so they can explore, they can burrow into wood or animal bodies or the soil and navigate the cluttered obstacle course of the soil or burrow into solid rock. All these different ways that fungi feed, and this is all how mycelium is their feeding habit.
It can actually do quite a lot more than we would necessarily realize, these networks. There's a sense in which they communicate, they move material around themselves. Tell us about what these networks can actually do.
Yeah, they're astonishing. They can navigate labyrinths, find the shortest path between 2 points in a maze. You can watch them nosing around microscopic labyrinths. It's kind of amazing to see. They have very efficient ways of searching space. You can take a fragment of a network and it would regenerate into an entire new network, meaning that these fungal individuals, if you're brave enough to use that word, are potentially immortal. One network can fuse with another network entirely to form a much larger network. And so there are many ways that these organisms challenge our animal imaginations.
So you talked about fusing of networks. This idea, I'm not sure if I pronounced this right, but this idea of mycorrhizal network.
Mycorrhizal.
Mycorrhizal, there we go, which is essentially different networks linking together, which can even connect plants together via this fungal network.
Well, yeah, it's easiest to think about it in historical terms. So in earliest days of plant life on land, these algal ancestors of land plants are little puddles of photosynthetic tissue sort of washing up onto the soggy shores of lakes and rivers. And these algae were not very well adapted to life on land, which was scorched and desolate and generally difficult compared to the nutrient broth that they'd been soaking in before. So they had this new challenge to deal with, which is how to acquire nutrients, minerals from the soil and water from the soil. And fungi were really, they're experts at this today, and they were experts at it then. And so an alliance began between these algal ancestors of plants and these fungi. And fungi behaved as the root systems of these ancestors of plants for the first 60 million years of their life on land. And so today, this still happens. And so 90% of plants depend on these root fungi to scavenge in the soil and to find mineral nutrients, which they exchange with the plants for sugars that they produce in photosynthesis. And so all plants, almost all of them, depend on these fungi. And these fungi are promiscuous. So one fungal network can connect with multiple plants, and one plant can connect with multiple fungal networks. And so this is what we mean by the Wood Wide Web. These shared overlapping networks of symbiotic fungi linked in trading relationships with plants.
So this so-called Wood Wide Web, it's essentially a kind of underground network that we don't see, we don't think about very much, but which is actually connecting all of these organisms together, and fungi are pretty much at the heart of it.
Yeah, so fungi form these literal connections between organisms, and in the Wood Wide Web we see this social network between plants mediated by these fungi. And I mean, the Wood Wide Web itself is a kind of affectionate term. It's a convenient metaphor, but perhaps too convenient. Because when we use it, it's easy to think about the plants as the routers, the equivalent of the routers in this network, and the fungi as the cables that link them together. In doing so, the fungi kind of recede from view. They become quite passive in this metaphor, but actually they're very active parts of the picture. They can funnel, redirect the flow of material around themselves, branch, fuse, form new relationships with different plants. So the Wood Wide Web is, yeah, it takes us so far. But only so far.
The network is the brain, and the kind of units that it connects are almost the kind of incidentals, or they are sort of secondary to it in some way. And one example of that were these ants that you told us about, where essentially the fungus seems to take over these ants completely and control them. Tell us about that.
So this is just one example. There are many, many different types of fungi which have arrived at this evolutionary conclusion independently. And so fungi don't have twitchy muscular bodies, the ability to walk, bite or fly. And so to spread their spores, many of them have worked out how to commandeer an animal body and to puppet its behavior to achieve some fungal end. And the end is spreading the fungal spores. And so the carpenter ants that you mentioned, this is one very well-studied example. There's a fungus called Ophiocordyceps. And this fungus, it grows into ants and it starts to wind its network through their bodies. And it produces chemicals which alter its behavior. And the ant's instinct is to stay low in the dark, in safe, relative safety of the forest understory. But when possessed by this fungus, it's compelled to climb up. It becomes fascinated with height. It's a syndrome known as summit disease. And the ant climbs up plant stalks, and at a certain height, which is the optimal height for the fungus to fruit, the ant is compelled by the fungus to bite onto the vein of a leaf, and this is known as its death grip. And then the fungus will run through the rest of its body and eventually will sprout a stalk out of its head. And as much as 40% of the mass of an infected ant can be fungus. It really becomes a kind of prosthetic organ of this ant's body. And once the stalk's sprouted out of its head, it can rain down spores on the other ants passing below and thus complete its life cycle. But what's interesting about these fungi is that these behaviors, these ant behaviors, are actually not ant behaviors. They're fungal behaviors. They're thought of by researchers in this field as a fungus in ants' clothing. So it's really starts to blur the lines of where one creature starts and another one stops. So they raise all sorts of questions about individuality. And there are many ways for this fungi to do this. There are other ones that affect cicadas and cause the back third of their body to disintegrate. And they have a very distinctive kind of erratic flight while they spout fungal spores out of their disintegrating back ends.
So you used the word possessed at some point. So essentially, we're now imagining quite a different world suddenly, where there are these invisible to us networks of fungus throughout every patch of soil in the planet. And they not only connect and distribute foods and communications between plants, they even inhabit or possess animal bodies. So suddenly it's almost a world in which the fungus is in control and the plants and animals are occasional puppets of their fungal masters. Am I taking this too far?
Well, in the case of these insect-possessing fungi, then you've got it spot on. When it comes to plants, it's more of a balanced relationship. You know, no one knows who's farming who. The mycocentrists say that the fungi are farming the plants, and the phytocentrists say that the plants are farming the fungi, and of course both are right. So then you have a much more balanced exchange. So fungal interactions with organisms can spread across a whole spectrum.
So if we, in the non-fungal world, we want to learn what wisdom you have gathered from this sort of mysterious underground world, what do you feel you've learnt, or what kind of more sort of philosophical conclusions have you reached from all of this?
So the idea of the individual is a very big one. And we're so used to thinking of ourselves as neatly bounded individuals. And in fact, we carry around more microbes than our own cells, without which we wouldn't grow and behave as we do. And so these microbes help us digest food, they influence our behavior, they protect us, help to protect us from disease. If they get into the wrong place, if a gut bacterium escapes into your bloodstream, it can go from being an ally to an enemy and can kill you. So we have this delicate, balanced relationship with trillions of microbes that coexist with us. And so we're not such a neatly definable biological unit as we might once have thought. Of course, bacteria themselves, large ones, can have small bacteria living inside them. Bacteria have viruses living inside them. Large viruses have small viruses living inside them. A large proportion of our genome started off in viruses. Many of the things that we take for granted that we do, like live birth as mammals, for example, that's only made possible by genes originally acquired by viruses. Then we look at fungi, and fungi wrap around the roots of these plants, they connect them into these large networks, but fungi have bacteria living inside them too. And the bacteria living inside fungi have viruses living inside them. So this is just the story of life. It's intimate relationships, it's symbiosis all the way down. What we think of as biological individuals may reflect our needs and our concerns more than biological reality. And so when we turn this idea of individuality into a question rather than an answer known in advance, I think all sorts of interesting things start to happen because we can start to reconsider the way that we form relationships, both with other humans, with other animals, and with other organisms that aren't animals too. And so for me, this has been a very big line of inquiry and a line of questioning that has arisen through my study of fungi.
So it almost sounds, your father is famous for a phrase, morphic resonance, Rupert Sheldrake. How does it relate to that, do you think? I mean, this is a science book, this is about a particular type of organism, but it also remembers some of that slightly more mystical atmosphere. How does it relate to ideas like morphic resonance, do you think?
I would say that in my concern with the way that fungi connect organisms, and in relation to my training as an ecologist, where you look at the way that organisms form relationships with each other and their surroundings, you have to look at those questions at higher levels than you would do if you were, say, a molecular biologist, where you simply wouldn't have access to those sorts of interactions that go on in ecosystems all the time. So in the sense that I'm concerned with the way that these things integrate together and form shimmering dynamical systems that form wholes which are greater than the sums of their parts. I would say that I have learned a lot from my father, who's concerned with looking at the way that things connect, looking at the way that things form wholes, integrated wholes, rather than always reducing systems to their constituent parts and hoping to find the answer there. So I'd say that fungi are easy ways into a more holistic view of nature because they're fundamentally interconnected, and you can't think about a fungus without thinking about who it's living with and where it's living. So I'd say that that's maybe one way.
Everything from government policy to economics is affected by essentially a kind of individualistic understanding of human beings as kind of units that interact via exchange or competition. What would this sort of alternative view of us lead to, do you think, in those kind of more practical realms?
I think we could learn to soften the boundaries of ourselves and to think of our bodies as made up of lots of nested cells. So if you think about your body as a community of cells which are working together cooperatively to produce this large differentiated organism which is you, and then all the microbes which are living together with your community of cells doing that, you have all these different levels of selfhood, levels of tissues accomplishing certain tasks, of microbes working with other parts of your body to accomplish certain tasks. And maybe if we could soften the boundaries of ourselves, or at least think about the way that selfhood might be a question rather than an answer known in advance, we might start to reevaluate our relationships. It's by imagining ourselves as neatly separable from each other and from the more than human world that we justify exploitation of the natural world or as other people. And so it strikes me that if we could reevaluate those relationships that we form, the way that we form those relationships, we might end up in some more perhaps responsible places with regard to the ecosystems that sustain us. If we see the ecosystem that sustain us and these flows of nutrition and energy that pass between us and the ecosystems, if we see ourselves as part of these systems, which of course we are, then it becomes harder to justify pollution or justify an extractive behavior that would sabotage a biogeochemical cycle on which we depend.
I mean, obviously at the moment we are in the middle of this pandemic. People are thinking about viruses a lot. Other diseases are caused by fungi. How have you experienced the past 6 months as a microbiome expert? Do you feel like the kind of conversation around this disease and around how we should understand it has been wise?
Well, it's a very interesting period because this narrative that we're in charge and we're in control and that large organisms with us at the top of that hierarchy are the clever ones, or at least the ones who know what's going on and have the ability to change the course of their lives, has been diluted somewhat because this invisibly small entity, a virus, not considered by many to be even alive, has interposed itself between us and our ambitions and has caused our systems to grind to a halt. So I think there's a humility which I've felt, which I've noticed very much in people who study microorganisms, because it becomes very clear when you study microbes that these organisms have been here long before large animals. They'll be here long after large animals have gone. It's really, the history of life is a history of microbes, and we're passing through.
I would say that, yes, there's been a humility in a sense, but there's also been very much a kind of idea that it could be controlled by different government policies and so on. And the conversation has been a lot about, which country has had the best policy and how it should best be directed. And essentially, if virus does well, it's considered a sort of byproduct of whoever's in charge. Whilst by your account, we may be much less in charge of even a pandemic like this than public policy experts like to say.
Yeah, as you say, we've been thinking about this as a kind of test for governments. And of course, if we were really concerned with dealing with this pandemic and future pandemics, which are the more long-term worry and are inevitable, we would stop doing the things that we're doing to make pandemics very likely. And we're doing a lot to make pandemics very likely, whether it be deforestation, all sorts of habitat destruction, which forces animals into different kinds of contact with humans and encourages these zoonotic leaps of viruses, or whether the liberal use of antibiotics in farming, which is a surefire way to breed new bacterial superbugs. So obviously governments need to be working with this current pandemic, but if those in power are really serious about dealing with these threats in the future, then we would start to reevaluate some of those destructive practices.
The whole kind of atmosphere of your book and what you're saying now it's almost a rebuke to scientism or an overly mechanistic view of the universe that I think potentially people are guilty of in fields as wide as agriculture and economics and politics. These are ideas that have been around since pretty much the Enlightenment, kind of reached a sort of dominance now. Any kind of critique of a purely scientific view of the world, at least a sort of mechanistic scientific view of the world, gets a lot of criticism in return, that it's either being irresponsible or that we are sort of, we're becoming sort of anti-science if they raise any questions about that method. How do we kind of strike that balance between sort of respecting the benefits and the huge advances of science while still being cognizant of its deficiencies?
Yes, so the mechanical philosophy arose as a movement in the 17th century as a way to make it easier to do experiments. If we can envisage the natural world mechanically, it makes it easier to intervene mechanically and to think about cause and effect in these mechanical terms. So it started as a metaphor, and these are still metaphors. These machine metaphors we use to understand the natural world. Of course, machines are built by humans, organisms grow. And so mechanistic perspectives have helped make countless discoveries of life-changing importance, and I wouldn't suggest for a moment that we abandon them entirely, but perhaps we could enlarge our stock of metaphors and populate our descriptions with those borrowed from other places, so that we don't forget that these organisms are living beings engaged in lives that we struggle to understand.
There's almost a kind of read across to politics in this as well. One of the controversies that you come back to a few times, which I thought was interesting, is whether the kind of symbiosis you describe between plants and fungi, where they're essentially kind of exchanging nutrients and behaving in a kind of almost economical context, whether it is truly a selfish, each plant or microbiome out for themselves arrangement, or whether it's some sort of more concern for the greater whole. You don't fully come down on either side, I would say, on that. But tell us about what you found and where your thinking's gone on that.
Yes, so when you're looking at these shared fungal networks, the Wood Wide Web idea, and you can have nutrients passing between plants, it presents a riddle for mainstream evolutionary theory, which struggles with the concept of altruism, because if an individual organism helps another organism at a cost to itself, then that organism will survive more readily than it, and its altruistic genes will not make it into the next generation, and so will eventually be weeded out. So there are a number of ways around this problem of altruism, and one is that organisms can help other organisms if they're kin. And so there are some experiments that have shown indeed that plants that are related to each other exchange more nutrients than those that are unrelated. So we might see some kind of kin selection going on in this plant Wood Wide Web world. But the quickest way around the problem is to flip the perspective. And so if you think about a plant, and material passing from one plant to another, you think, well, why would this plant help its neighbor at a cost to itself? You end up in the altruism trap. But if you flip the perspective and you think about this fungus which has a portfolio of plant partners, and in the interest of the fungus, to keep these plant partners alive. And if one dies, then the fungus has others that it can survive on instead. So if you see it from a fungal point of view, passing these nutrients to equalize the resources within this small part of the community, you don't end up in an altruism problem. So this is the way that people have been thinking about it in the research community.
I mean, there are passages where you're describing these sort of various nutrients and how the price, as it were, goes up or down depending on the scarcity in different parts of these underground networks, which sounds like a sort of capitalist dream, a sort of finally proof that the underground life is behaving in a kind of Adam Smith market way. But then at other times, as you say this is underground socialism in action, and actually, that all of them are having kind of care for the whole in order to survive. So essentially, it's both.
So as is always the case with the study of symbiosis, these lessons that we hope to extract from the natural world tell us as much about ourselves as the natural world that we're trying to describe. And it's a very common thread in the history of the study of symbiosis. These relationships have always been conceived of in human terms. The study of symbiosis behaves as a kind of prism through which our social values are refracted. And it's one of the most interesting things about the history of this branch of science. And so I think it's more helpful just to think about collaboration as always an alloy of competition and cooperation. And these two things are always in some kind of dynamic state of existence. And if you want to find in the natural world some example of terrible, or apparently terrible exploitation, then of course you can find that example and you can pin it up on your wall. And if you want to find an example of a heartwarming cooperation, you can also find that. But this idea of collaboration as both competition and cooperation, I think, is quite helpful because it helps to take us into maybe a larger room where we could admit that the course of evolution has been driven by both competitive forces and cooperative forces, rather than having to side firmly with one or the other.
There was one example that I remember where you talk about how different parts of these underground networks communicate and how they become aware of what's happening elsewhere in the network. And the analogy you give is screaming. So if something bad is happening to a plant, say, that is connected to this mycelial network, it's the equivalent of a scream. And the question there is, are they screaming for help, or are they just screaming, and are they being overheard in screaming? So I thought that was quite an interesting way of seeing it.
Yeah, so that was the screaming metaphor is used in discussion of how signals can pass between plants through fungal networks. The phenomenon is well established. The question is how and why. And so some people say, well, the plant it's a sort of an active process. It's signaling to its neighbors to alert them of the impending attack from some herbivore, aphids or whatever. Others say, no, that's not what's going on, because it wouldn't be in their interest to signal that to their neighbors. So actually the neighbors are just eavesdropping on their stress, and their stress is passing through as some kind of chemical signal through the network. And we don't have the tools to resolve this causal arrow right now. It's often the case in interactions that it's hard to resolve the causal arrow. If you had a human situation, someone was attacked in the street, they screamed, and someone came to their rescue, then the question of why they screamed, even if you asked the person outright, did they scream because they were upset or in shock or in pain, or did they scream to alert someone else, or both? That person might not themselves be able to tell you which one or both it was. And so imagine trying to get that information from a plant.
There's a whole sort of, I was about to say subterranean community, which occasionally you describe in this book that most people are probably not aware of at all, which are fungal enthusiasts, and they crop up rather like mushrooms in these kind of conferences that happen around the world. Describe that community. What sort of people are they? Are they kind of conventional scientists? Are they sort of mystics? How would you describe the global fungal community as you've encountered it?
Well, it's enormously diverse for a start. You have people who are passionate mushroom foragers, and you have all sorts of different mushroom traditions in different countries, and going back quite a long way. And you have people who are very interested in mushrooms and then became interested in fungi more generally. And so the scene I was describing in the book is one that started really on the west coast of North America, and it comes out of this more general trend in it's a kind of DIY hacker culture, biohacking as civilian science, people taking the study of science outside of its conventional home and university departments and putting it back into people's garages and gardens, where it actually started hundreds of years ago. And so it's part of this DIY scene that you find a lot of this mycological activity happening in the States. And these myco-hackers do an enormous amount. And there's these forums that sprung up online when, from the early days of the World Wide Web, of magic mushroom growers, finding new ways to cultivate magic mushrooms in their garages and kitchen sink mycology. And these techniques, it turns out, are generally applicable to all sorts of other aspects of mushroom cultivation or fungal cultivation. And so there's this very bustling and innovative community of people who are conducting quite serious research, but outside the purview of conventional academia. And so it's really, it's quite an exciting place. There's an atmosphere of incredible motivation.
Motivation to what? What's the sort of holy grail? Is it, because some viewers will no doubt think that it's a sort of hippie kind of drug community in some way, that, it's magic mushrooms, everyone is sort of looking for the perfect trip or whatever. You would say that it's a lot more than that, in which case, what are those other goals?
So many of these people are not growing magic mushrooms at all. I mean, a lot of them are just growing gourmet mushrooms, which is a good way to make money, because you can use agricultural waste, material that would otherwise be thrown away, and you can turn that into a valuable cash crop that goes quickly in small space and can be sold to restaurants with a lot of value added. So there's that part, the culinary part. But with regard to the motivation, there are lots of different ways that these DIY mycologists think about it. A lot of them are concerned with gardening and agriculture and developing more sustainable agricultural techniques based around concern for the health of the soil and composting methods and new ways to build systems in agriculture that don't depend on heavy doses of industrial chemicals. And there are other people who are concerned with developing ways that fungi can be used to break down poisons or help with environmental cleanup operations, something known as mycoremediation. Fungi have amazing appetites for things like crude oil, for example, and so people are working to develop systems to help to remediate polluted environments using fungi. So you see a whole blend. You see people who are concerned with making things from fungi, making materials, building materials from fungi. This is actually quite big business now, and Dell is shipping thousands of servers a year in fungal materials, fungal packaging. IKEA are in the process of reimagining their entire packaging market to incorporate fungal packaging. So there's all sorts of fungal applications, and you see all of these converge in quite a polyphonic way in these mycological hacker scenes.
Because you find, at least here in the UK, I find even in the kind of mushroom context, there is a weird aversion to it. You talk about some societies being kind of mycophiliac or mycophobic. I would say the UK is predominantly a mycophobic culture, at least compared to Sweden. Certainly, if you stop to pick a mushroom in the UK, you quite often might be stopped in your tracks. People say it's a toadstool, stay away. So there's a sort of job to do to rehabilitate the reputation of the mushroom.
Absolutely, yeah. I mean, many parts of the world, there's a very long history of deep fungal involvement in culture. Like in China, for example, the person who discovered how to grow shiitake mushrooms in the year 1000 or thereabouts, there's a feast day every year and temples built in his honor. This great national hero. who worked out how to cultivate this medicinal and nutritious mushroom. So it's hard to imagine something like that happening in England, for sure.
So give us a kind of concluding thought. You've thought so much about this, you've been so closely involved that you've almost imagined the world as seen by a fungus. Do you feel you behave differently since that? Have you learnt things from fungi? And do you think you now, in your sort of daily life, are remembering those lessons in some ways?
Yeah, I mean, I think that thinking about fungi makes the world look different. And when the world looks different, we start to behave differently. And that's really something that I've noticed in myself. When I am handling a plant, I realize that, oh, this plant is this alga which has evolved to farm a fungus, and a fungus which has evolved to farm an alga, and this plant life, which I think of as a plant life, is also a fungal life, or a many fungal lives. And just that thought, just that realization does quite a lot to change my relationship to the plant. That what I'm going to do, I'm going to cook it, and however I touch it, however I handle it, my attitude changes. So there are lots of ways like this that my behavior has changed in small ways based on realizations that I've had to do with the fungal world, and the way that the world we think of as our world is very much a fungal world. There's another is to do with the relationships that form between organisms that may be invisible. You know, we form these, we have these encounters with other humans, with other organisms, other plants, with others, and these encounters don't usually leave an enduring physical connection. But once you start to think about fungi and these actual enduring physical connections, then it's easier to see the way that these dynamic relationships form and evolve in other aspects of our lives, maybe that aren't actually visible as enduring physical connections. And so it's easier to remember that we're bound up within these shimmering constellations of activity in these constantly evolving processes, and that this relational awareness is something that can really change the way that we go about our lives. I personally have found that it changes the way that I go about my life. So there are many sort of small shifts in perspective that add up after a while that I've found.
So the next time we see a mushroom in the forest or on a walk, we need to remember that it is not a little unit growing out of nothing. It's actually the tiny visible tip of a vast underground network.
Absolutely.
Merlin Sheldrake, thank you very much.
Thanks for having me.